Welcome to The Explainer. Today, we're talking about something that's a bit like gazing into a crystal ball for software. It's this critical, often invisible task of trying to predict the future. We're diving into what's called test estimation. So, let's kick things off with a question that probably hits a little too close to home for all of us. I mean, we've all been there, right? You're waiting forever for a new app or a cool feature that's been delayed. And then when you finally get it, it's just full of bugs. It is so frustrating, and it seems to happen constantly. So what gives?
Well, a huge part of the answer, it's right there. It comes down to something called test estimation. You can think of it as both an art and a science. It's this whole process of predicting just how much work it's going to take to make sure a piece of software actually works the way it's supposed to, without crashing.
Okay, so what does that effort really mean? Let's get into it and define what goes into a good, solid estimate.
All right, at its heart, test estimation is really about making a very educated guess. You're looking at a whole project and trying to predict the three big things. The effort, that's your team's work, the cost, so the actual budget, and of course, the time on the clock. And the whole point is to do all this while making sure you hit a certain level of quality.
And this whole complex challenge, it really boils down to answering two fundamental questions. First, what tasks are we even doing? You gotta list out everything. And second, how much effort will each of those tasks take? It's the what and the how much.
Now, answering those two questions, it sounds pretty simple, right? But of course, in the real world, it's not that easy. There are all these different factors that can completely throw your estimate off track. So let's look at the big variables that can change everything. First, you've got to look at the product itself. I mean, is there good documentation to work from, or is the team basically flying blind? What's the size of the thing? Testing a little calculator app is completely different from testing a huge e-commerce site. And then there's the complexity. The more moving parts you have, the more opportunities there are for things to break. Next up, you have to think about your process. What tools does the team have? Are they using fancy automated testing, or is everything being clicked through by hand? And the development model is a huge one. Are you using an agile approach, testing in small, quick bursts? Or is it more of a traditional waterfall model, where testing is this one giant phase at the very end? Totally different ballgames, totally different estimates. And this is absolutely crucial. You cannot forget the people factor. What are we talking about? Well, the skills of your team. Are they grizzled veterans or fresh-faced grads? Do they actually have experience with this specific type of testing? And then there's pressure. A team that's under a crushing deadline, well, they might start cutting corners, and that's going to have a huge impact on quality.
Okay, so with all of those variables flying around, how in the world do teams actually come up with a number? Well, it usually comes down to two main schools of thought. You either trust the data or you trust the experts.
So on one side, you've got the metric-based approach. This is all about the numbers, looking at past projects. How long did the last similar project take? How many hours went into testing? Then on the other side, you've got the expert-based approach. This one relies on gut feeling, on experience. You basically just go to the people doing the work and ask them, hey, how long do you think this is going to take?
And this is a great example of that metric-based approach in action. You can see how, by looking at old projects, a team gets this really clear data-driven breakdown. They can see, okay, about 30% of our time is spent just writing the tests. Then another 35%, the biggest chunk, is actually running those tests. And that other slice? That's often for super important stuff like user acceptance testing, or UAT, which is where real users get their hands on it and give the final thumbs up. Having this kind of historical data gives you a solid, fact-based foundation for your next estimate.
Now, the expert-based method, that often uses something called a work breakdown structure. It sounds complicated, but the idea is simple. You take the whole project and you chop it up into big categories, like planning or design. Then you chop those up into smaller groups of tasks. Then you go to your experts, the lead developer, the main tester, and you ask each one to estimate just their little piece. You add it all together, and bam, you've got your full project estimate.
So which one is it? Cold, hard data or the gut feeling of an expert? Well, you've probably already guessed it. The best teams, the really successful ones, they don't pick a side.
They use both.
And they often bring them together with this really powerful formula from a technique called three-point estimation. It looks a little mathy, but here's the deal. You ask an expert for three numbers: the absolute best case scenario, the total disaster worst case, and then the most realistic, most likely guess. But here's the magic trick. You multiply that most likely number by 4. What that does is it heavily weights the final estimate toward realism, while still giving a nod to both wild success and catastrophic failure. It gives you a balanced and, frankly, a much more defendable number.
So everything we've talked about, the different factors, the techniques, that formula, it all builds up to one final and really important shift in how we think about this. It completely changes the question we should be asking.
And that right there, that's the big takeaway. Once you understand test estimation, you realize that asking when will it be done is kind of the wrong question. It's just asking for a guess. The smarter question, the one that's way more helpful, is what do we need to know to make a good prediction? See how that changes things? It shifts the whole conversation away from just talking about a date on a calendar and toward a real discussion about knowledge, about planning, and about risk. And honestly, that's a much, much smarter way to build anything.